Again, I'm going to make this response variable really large so that we can actually hold all of the data that we get back from the various clients that we might be requesting information from. So I haven't actually specified the request yet, because that's going to be our actual HTTP request, like we talked about a little bit in the slides, and I'll explain what all of these things mean. So the very first part of any HTTP request, as according to the protocol, is the method. It's what you're doing with a particular resource on the server. So in this case, we're going to get. The next thing that's part of our HTTP request is what resource we're going to get. We're going to specify a / to just say, basically it's like the root location on this particular server. It's like when you request a website without specifying a particular page. That's what this / is going to indicate. And then we specify the version of the protocol we're using. That's HTTP 1.1. And then, like before, we use \r and \n to denote that we're finishing up this request. And we're going to use 2 of these here. So we have our HTTP request. So now that our socket connection is already made, we first send the request using the send method on the socket. So this is basically all we need to do to send a HTTP request, similar to the send calls that we've seen earlier with our TCP client and server. And after we're done sending, we receive the response using the receive method. We pass the address of the place we want to store the response. And again, both send and receive take an optional flags parameter that we're just going to set to 0. So now that we've sent our HTTP requests and received an HTTP response, we are going to print out what we got back from the server. We're going to use a format string to basically give us some extra information, format it a little nicely. Use a new line at the end of this here. And then we're going to close the client socket. So we send our HTTP request. It's a GET request for a particular resource. And then we receive data back from the server right after that, and we're going to print that out. So like our basic HTTP server, this client is just sending GET requests. But there's a lot of other methods that you can perform on particular resources in the HTTP spec. Much like the server, there's GET, update, delete, there's a bunch of different things. But since this is a really basic HTTP client, we're just going to get resources, and that's kind of what we were able to do with our browser. So let's test this client out and make sure everything works properly. So when you attempt to compile the HTTP client, you might get a warning about your call to the inet A2N function, but you can safely ignore that for the purposes of this. The program should still have compiled, and you can pass it some IPs and start testing it to make sure it works properly. So to test it out and make sure I can get some data back from any particular server on the web, I'm going to use our HTTP client to grab some data from google.com. So I'm first going to grab the IP of a Google server. I'm going to use ping to just find that out really quickly. So you can see here we get an IP, and we can use our HTTP client to request some data from this IP. So as you can see, we get back a full HTTP response. Like in our server, we got back a first line containing a status code and the HTTP version message, and then some more headers, basically metadata about the response from the server, and then we get some actual content from the page. Some HTML, some text, things that you might see when you actually load the page in your browser, but this is just giving us the raw content of the response body. So, using both the HTTP client and HTTP server, you can get an idea of how we can use sockets to underlie all parts of the web process, both on the client and server side. Sockets are used to actually implement servers, respond to requests from clients. We just looked at basic examples, but you could extend these with more functionality and actually have a fully featured web server directly with the sockets technology we looked at in C. So this kind of gives you a little bit of an idea of how sockets are the basic building block of network communication. On both sides, extending these applications would lead to some of the full-featured things that you'd see on the web. You could display dynamic content in the same ways, but it all works based off of sockets. So we've covered how sockets work and how to implement applications with sockets. And from there, that's really sort of the basics of getting started with socket programming. For more information on implementing specifically the HTTP protocol over top of sockets, there's good information available freely on the web. If you want to get in depth, you can go ahead and read RFC 2616, and that has all of the information. It's a comprehensive guide on everything you need to fully implement HTTP, all of the methods and everything involved, what needs to be defined on an HTTP request and response cycle.